Hello there and welcome to another performance related Business Central AL programming video, and today we are going to look at the non-clustered column indexes.
Hii ni Tech na Msangi ya jishinde.com.
And so I have opened the base application, and this is the GL entry table of the base application, and this is how it is defined. Remember, there are so many flow fields, especially in the GL account table, which fetch data from the GL entry table. And when you look at this table, it contains several fields, yes. And where the keys are defined, we do have a key for the primary key and secondary keys, which do contain the sum index fields. So what we are having here, we have a sum index field for the amount, debit amount, credit amount, additional currency amount, etc. And what does this mean to SQL Server when we have a sum index field defined? What does it translate to in SQL Server? When we open our SQL Server, we can go to the views and scroll down to the GL entry views, and we can basically, they are named after the keys. So if we look at the, for instance, the key 2, let me just expand this for better visibility. So key 2 contains a composite secondary key for the GL account number and the posting date. So there is a GL account number here and the posting date. So that is a composite key. So there is a unique value for each GL account number and posting date, and it maintains an aggregate value of the amount, debit amount, credit amount, additional currency amount, VAT amount, quantity. And so these are the amounts that do have a maintenance of a sum field. So this is an index view that has been created by the sum index field technology. So when we define those fields, we need to be really careful, because behind the scenes, this is what we are creating. We are basically creating a new view, and it contains aggregates, and they are stored for each unique value. Of course, it helps to speed up some aggregate summations, but the caveat is maintaining this for every insertion, every update operation. We need to do a similar operation to the views, because the data needs to be maintained for it to have the latest information, and it might lead to table locks in the event where the table where there maybe the transactions are too many. Of course it will lock, or in the event where the system is quite slow, it could lead to table locks. And if the field is not needed for some operations and all that, then there is no need of defining it in the sum index field. It should only be defined only when necessary. Okay, another technology that is in the non-clustered column store, non-clustered column indexes, that is it ought to replace the sum index field technology. And this is how we are defining. So this is a table from a Microsoft Learn documentation that states how. So this is ideally, maybe you have a student table that contains the ID code, first name, the points, and the number of courses. So we can define a SIFT index on the code with aggregation fields for count and sum. So once we define a SIFT index and we say that we are having a sum index field technology, then we will be able to get the sum. So we do have a property that like maintain SQL index sets the value that indicates whether an SQL index that corresponds to the fields part of the Dynamics 365 in the central should be created. So if we don't want it to create an SQL index, then we say false, because ideally it will create an index view and an SQL index which will be maintained. So if you say false, an index won't be created. But okay, so this one, the same way the GL entry has created as an index views that will be maintained also, in the same way this student table, which is filtered here, so by default, okay, let me look at this property again. Sets the value that indicates whether an SQL index that corresponds to the fields part of the Dynamics should be created. So I think this property, the index should be created because the index has been created and it's already okay, so there's no index created. Sure. Okay, I thought that there was an index created, so it's okay. So there's no index created for the student table. This is NCCI. Let me look at this. If there is any index for the SumIndexField technology as well, there is only the primary key and the unique value. So if we say sorry, if we say true here, then an index will be created, but at the moment there is no index that has been created. But on the contrary, an indexed view will be created, and if I go to, we'll have two for our purpose for the student because we have two SIFTs. So there is the key on code and key on names. If you look at the last part of this index, there's a key on code and key on names. And if I am to select at least the top 100 for each, so we do have the key. So the names, I think I didn't have any first name that was unique. It wasn't keyed in. So we are having the count because it is using the uniqueness of the first name. But again, the code, there's unique values for it. And we are having a count and a sum. So for each code, there is a summation for it. And remember, this will be maintained. And this is what we have defined. But you can choose to migrate to a non-clustered column store index. And what this gives us on the difference in defining the two tables, here we'll only have the primary key, but we'll add the property of column store index, which will set the fields that are added to the column store index inside SQL Server. So we are using the non-clustered column store index technology in SQL Server to do our aggregates, and we define all the fields that should be aggregated. So instead of having several index views which will be maintained over and over again, we only have one column store index. And what happens when we have our column store index? So how was it created? When I try to script it in a query editor and we see how it was created, this is how the non-clustered column store index was created on these fields. And then so with the drop existing, compression delay, data compression is column store on primary. So this is the location where it will be stored, the physical the primary group. Okay, what was it called? File group. Yeah, primary file group. So the data compression is column store. So what this does, so the a disclaimer here, we should only use it for big tables, for big analytics and processing. To be specific, tables with records over 100,000, at least with over 100,000 records, then this one makes sense. Otherwise, with small tables, then it doesn't add any value because it slices the rows before it creates a column store. A column store contains a row group, and a row group contains a minimum of 100, I think it was 102,400 rows. 102,400 rows. So that is a number that should be contained in one row group, which will be compressed and formed into a column store. And what that means, once that has been done, there is no need of maintaining it over and over again, because that row group is already there. Unless there's a batch deletion, the system will automatically come and remove it from the column store and rearrange. But as long as mostly should be used like for the GL entry table and data that is not really deleted, ideally data that does not have a lot of movement, data that is used for analysis most of the time. And the beauty is we don't need to maintain the index. It is not expensive. There will be no table locks in it. And I tried just a few queries with now my student. The two tables that I have here, there is the student non-clustered column store index and the student for the SumIndexField technology. So these two tables are in SQL created, and I can be able to analyze and see if there is any improvement in performance or so. So let me think I had okay, so here is the first query. So this is for the SumIndexField technology with statistics IO on. I'll execute. So it is basically doing more logical reads. So we have like 82,271 logical reads. We'll look at what that means and just a minute. I think I had the other query, but I can just copy this. So this table are the same. The only difference is the last part. So we can have them run and we'll have two different results and messages. So in the first one, at least we are having them in the same window for us to view. I don't know if this one can be maximized and better view at 200. Yes. So this is the view with the statistics. One row affected, of course, and so this is the one for the SumIndexField technology. We did one scan, but here we had 3 scans. So it means we definitely have done more scans, but we have more logical reads here and less logical reads. Physical reads 0. Okay. So lob logical reads are more here. Okay, I'm not an expert in SQL, so I've not really gone deep into what this means. But at least we are achieving results that are fast with, okay, so these two tables contain 4 million records, and we are achieving results that they're just relatively fast. And remember, we are having an advantage of not maintaining the physical, okay, we are not maintaining the index. So let me just look at scan count. So what is this? So scan count is n when n is the number of different seeks and scans started towards the left or right side of the leaf level after locating a key value using the index key. So number of pages, the number of pages reads from the page cache. Let me see this, if it has that. So we have the scan count. So this is the number of 6. So if it is 0, the index used is a unique index or clustered index on the primary key you are seeking, for example, and there. So if it's 1, you are searching for one value using a unique and a unique clustered index defined on a non-primary key column. This process is done to check duplicates and etc. So, and it's n of n when the number of 6 started towards the left or right side of the leaf level after locating a value using the index key. So the logical reads number of pages read from the data cache. So it means on this side, our cache is having more data. So we are having less data read from the cache. I don't know if this is a benefit, to be honest. Let me go back here. So number of pages read from the data cache, physical reads number of pages read from the disk. Okay, number of pages read from the disk, it was 0. So let me look at this. Lob logical reads. Number of pages read from the data cache, so which includes text, n-text, image, varchar, and all that. So we are having this read more from the data cache, this the non-clustered column index store, but because okay, it contains this data that has been compressed into column stores and the row groups compressed into column stores, contrary to the SumIndexField technology. Okay, what I'm doing here is also analysis, trying to see which could be better, but I believe the one you still need to monitor if it has got an impact to your analysis. Once you either apply, you change, maybe from you migrate from some index field technology to this column store, non-clustered column store indexes. But I believe for tables such as legendary tables, which do have information really stored there, not deleted and moved from time to time again, I believe this one will be more beneficial. It could be using more CPU memory to process, but in the long run, if we save the user from the hassle of table locks, actually that is just a big win for me. No big difference for 4 million rows in terms of how fast it is doing either of the summations. Like if I just execute, this one is just almost the same, no much difference here. And yeah, just slightly different, but I believe it can really be impactful if we can solve just the part of table locking. We solve the part that we have eliminated locks in processing, especially for big data sets. So that's it for this video, and I will see you in the next video.
If you enjoyed this video, make sure to like, subscribe, and ring the notification bell so that you don't miss the next one.